Okay, well, good afternoon and welcome everyone to today's presentation. My name is Ladd Nelson with Carlson Software, and today we've got one of our medallion dealers, Jennifer DeBona of That CAD Girl, doing a civil tips and tricks for some Carlson Software routines that she will be demonstrating today. And throughout the afternoon, or this afternoon session, we'll be actually fielding questions. So if you have any questions for either Jennifer or myself, feel free to chat those into the chat window in your GoToMeeting control panel, and we will answer those questions. And if there are anything towards the end of the presentation, again, we'll address any questions that we don't cover actually during the session itself. So with that, Jennifer, you have the floor. Take it away.
All right, I'd like to thank everybody for attending, and it looks like we have at least a few people who tried to get into the noon Eastern time webinar that didn't go off quite as planned, so glad to have you all back. So as Ladd said, we are presenting today civil tips and tricks for Carlson software, and the plan here is to show you little bits and pieces that most likely you have not even seen in a demo, so this is beyond the demo. So a couple of the items that we will be hitting are doing some road widening, working with templates in the RoadNet. So anyone that has Carlson or has seen Carlson has most likely seen a RoadNet presented, since it's one of the hot features, but I'll take that just a little beyond what you may have seen in the demos. We've also got some polyline labeling that is kind of a slick thing for design. We are going to look at working with points on a slope, which is a new feature for Carlson 2010 that combines a lot of their point setting features using various methods. We'll also cover SiteNet, which is a feature that originated in the Takeoff package, but is very powerful for determining earthwork calculations, material quantities, specifically topsoil quantities that I'm going to hit today. And also, if we have time, I'll show you just very quickly some multi-pad grading. So let's go ahead and get into it. Actually, I've got a couple slides here. Just upcoming Carlson webinars, we do have these listed. We have several more planned even beyond the June 17th one that is listed here, so I'd encourage you to check that out. And then as well, I'm holding a few hands-on training classes here in Raleigh, North Carolina that will cover a lot of things hands-on that you may have wanted to see a little bit more of. So with that, now we'll go ahead and switch into AutoCAD. And what I'm working with today is the Carlson Civil Suite 2010 product on top of AutoCAD 2008. And what I have on the screen is just a simple little subdivision with a RoadNet already defined, already built. So I'm just going to hit the process button here for RoadNet, and you'll see it build. So again, I have all this done already. I figure most everyone here has seen that before. But what I would like to show you is a little bit about templates. So I'm going to open up my Road 1, and you see that I have a template defined, which is Road 1. And I will pick Edit. And I want to show you a little bit about what I've done with this template that those of you using it may not be using it to its full extent and to get the most benefit out of it. So the primary roadway element here is a graded element that goes from the center line out at 13.5 feet, and I have designated that as my edge of pavement. So nothing too special there. However, let's now look at the subgrade that's associated with that. So the subgrade, I have an asphalt, so 2 inches of asphalt, and I'd like for you to see how I've defined that. So you can see that the asphalt intersects the surface by going straight up. It is 2 inches of asphalt. And notice here with the distance, and this is a very important feature that, again, is not terribly obvious. Instead of just simply typing in 13.5 feet here for the distance. So remember, this is my asphalt and how it's going to be defined in this template. So instead of giving my subgrade of asphalt a distance of 13.5 feet, instead I've defined that as EP, which will reference this EP template ID point that I defined here, where my mouse is showing. And the significance of that, the benefit of that, means that if I have a turn lane or any kind of a widened or an adjusting edge of pavement that I define, as I set up a template point center line that has my edge of pavement following a different alignment, then the subgrade will automatically follow that edge of pavement defined here. So let's actually look. I don't know if that made a lot of sense what I said there, but let's look at a couple other things. This is my asphalt that I'm showing here. See that I have it defined material. And then the stone underneath it, you can see in the graphic display that it wraps around the curb, and it actually goes 1 foot behind the curb. So how did I define the stone subgrade for this template? Notice that again, I'm referencing everything to the edge of pavement template ID point here. So the stone is to go to the edge of pavement, wherever that may be, and go 3.5 feet beyond that. Okay, and then with my the sidewalk subgrade, notice that the horizontal offset, I have set this to maintain 4.5 feet beyond the edge of pavement. So it starts 1 foot behind where that stone is going to start. So let's do a save as. I'm going to create a second template. So right now I'm working in road1.tpl. I'll do a save as, and we'll just call this road 2 template. And then I'm going to make some changes to this. So my edge of pavement for my smaller roads, I want to be a 12-foot pavement section instead of 13.5. So it's a little tough to see, but the only thing that I have to adjust is that edge of pavement. And because for my subgrade, my asphalt and the stone and the inside edge of the sidewalk is tied to edge of pavement, when I make this change, everything here will shift accordingly. And because it zooms out, it's kind of tough to see. But you can see that I'm showing a 12-foot edge of pavement here. And there's the asphalt that has adjusted as well. There is the stone that's adjusted and the concrete that's adjusted along with its surface area. So I'll save that, pick exit, and now I need to assign that template 2 for both of my smaller roads. And once I hit save, and it's important to hit save here for your road network, I will now hit process. And you'll see if I zoom in that the sidewalk, you can see that the pavement has shifted. It has followed it now. So it's a 12-foot section here compared to a 13.5 section here. And the sidewalks all match up exactly as I wanted. So now that I'm out of RoadNet, I want to show you another quick tip that, again, you may not be aware of. And that's a handy little feature here called Draw Typical Template. When you pick Draw Typical Template, it lets you select the template you'd like to draw. And then the settings that I have set here are normal. And then I'm having it label surface only, and there are a bunch, obviously, of other settings that you can change. And I'll have it draw it in the drawing for me. And you can see how nice this is. Again, coming from a design from production, knowing how these typical templates, typical cross-sections are normally put together in a pinch when we're in a hurry trying to get a set of plans out the door. Normally, you'll say, you know, where can I find a typical template? Well, you go back to that one we worked on 6 months ago and just bring it in, copy it over from that drawing, and the only thing different is we're using 1.5 inches of asphalt instead of 2 inches. Just make the text change and go with it. So knowing that that's how I used to do it and how it's still typically done, this is a pretty powerful little tool, because for those engineers, those people that have to sign off on this, if you go to this Draw Typical Template command and pull it from the road network file that you've been working with, you are assured if this comes in wrong, you know that that design is wrong. So any quantities that you've pulled from it, any of the design may also be wrong if you see a problem here. So it's all about QA and QC and making sure it's done right. So this is something hopefully maybe new to a few of you. So let's see what else we can do with the RoadNet that maybe everyone doesn't typically use. Just to start off with, I'm going to clean up and just get rid of the break lines and the contours that are shown here. And of course I can get that right back if I need to by rerunning and processing the RoadNet. But I have another layer that I'm going to turn on, and this is just a little turn lane. And I want to show you very quickly how easy it is to apply a turn lane to a road network file. The only thing that I have to make sure, this is a polyline, and I have to make sure that it is drawn in the direction, in the same direction that the road I'm going to associate it with. So actually, let's just use the drawing inspector, which for 2010 has an option for display polyline direction. So if I hover over that center line, you can see it's going in that direction, and the polyline next to it is also going in that direction. So that's all I have to make sure of, and I will turn off the drawing inspector. And the next step is to simply define this edge of pavement as a center line. So I'll go to center line, polyline to center line file, and I will call this Road 1 REOP for right edge of pavement. Beginning station does not matter. Again, you do not have to worry about trying to get stations to match up. It's only the direction that matters. And I'll select this edge of pavement polyline and hit enter to finish that. Now that that's defined, I'll go back into Road 1, and I'm going to define this as a template point centerline. And just by selecting here, I'm going to create a new template point centerline file, and this file that you're creating will work with both right and left edge of pavement. This is a file that's created for each road. So for Road 1, all of your template point center lines are going to be associated in this one file. So I can just simply name it Road 1 to keep it clean and neat. And then pick the Edit button to the right. And I'm going to add an alignment to this template point centerline file. The template point description, you may know it, you may type it in here, but I prefer to list. And this brings up a list of all of the template IDs that we defined in that template. So I'll pick OK for that. And then select a file to associate with that edge of pavement. And it's this one. The side to use it, if you're facing up station, this will be on the right, and we pick OK. I'm going to hit Save and OK, and that's all there is to it. I'll hit Save and process for that. And if I zoom in, you can see that that has pulled away, and you can notice that when I defined that or drew in that edge of pavement for the turn lane, I didn't even have to do anything for the fillet going around that corner, so it takes care of that for me. So that's how easy it is to add a turn lane. Let's look at a couple other things. Again, I think I'm going to erase by layer all of the contours and brake lines so that you can see a little more clearly. And now what I want to show you how to do is to elevate building pads and sidewalk lines based on your road design. And let's be very clear, what this is going to do is simply elevate these polylines. It does not build these entities or these features into your surface simply by doing what I'm getting ready to do. It will just elevate the polylines. So this is all managed. Actually, let's just look here. I'll turn back on my drawing inspector and turn that off and turn that off. Okay, I'm stuck in a loop. Okay, never mind, that didn't work. So this is on a layer called 2D building pad. So all of these building pads are at a 0 elevation right now. And these lot lines are all 2D as well. And I'm going to need my drawing inspector. So let's see if I can not get that turned off. All right, Lad, if you're paying attention, if you know anything that I'm doing here.
The only thing I could think of would be to try maybe shutting down the road network dock dialog box for just a minute and seeing if that will clear it out.
Nope.
Okay. If you go into your settings menu and just maybe trying it from the menu pull, or sorry, inquiry.
It doesn't let me change the options from there. Yeah, now it won't even let me get the settings. All right, well, we'll just do it another way. I think I've just gotten stuck in some kind of a loop. Okay, well, it's turned off. All right, thanks, Lynn.
Mm-hmm.
All right, so I'm going to get all the way out of this, and it's now looking like my entire drawing is somewhat sick. So okay, so let's try this again. So the good news about working with RoadNet is that we don't lose anything because everything was still saved in my road network, so it's all here. So let's look at now just trying to elevate these building pads. We'll figure out how to check it in a second. So under Output Options, the first thing I'm going to do is just elevate the pads. And just for demonstration purposes, I like doing this in 2 steps. So under Elevate Pads, I can pick Setup. And this allows me to set the pad elevation based on a point from my template. So again, I'm going to pick Select. And this loads in all of the template IDs that I had from my template. So I'll pick OK. So I'm going from the shoulder point. The pad layer. So all of my 2D building pads are on that layer. Maximum offset set to 100. So any polylines within 100 feet of my shoulder point that are on this layer are going to be elevated in this fashion. My reference elevation, so what this is asking, do you want to take as the building pad goes along the road, do you want to find the highest shoulder point, the lowest shoulder point, or the middle shoulder elevation point? And I'll just pick the highest. And in this case, I want to set a vertical. So I want to go 2 feet above the highest shoulder point in order to set that building pad. So I'll pick OK here and pick OK here. The only change I've made is there in Settings. I will hit Save and then Process. And you'll see everything design again. And actually, let's do it this way. Let's see what the elevation of that building pad is. So instead of using the Drawing Inspector, I'll go to 3D Data, Label Polylines, and I'm going to Label Pad Elevation. And I'll have it set to FFE, Finished Floor Elevation for the prefix. And the layer, I'll just, I'll put it on layer 0 and pick OK for this. And now I can just select that. Actually, I'll do all 4 building pads. And it has labeled their elevation. So this may not be too smart, but I'm going to try Drawing Inspector again. Did it actually work? All right, so we got that working. Let me turn that one off too. All right, so the elevation is 275.57, and if I'm able to find that shoulder, we should see 275.57. So that is why we set that elevation and where it found it. So again, it's kind of a neat little command that allows you to set some of the elevations here to get a start on designing your pads. And then let's just go right back into Settings and Output Options and do the same thing with Elevate Lots. And this again is going to come from a point on my template. So in this case, I'm going to come from my shoulder, and it's going to look for a normal slope, which is going to be 2% coming off that shoulder. And I will have it go at 12.5 feet, which is about where my building is set. It's a little further than that. For 12.5 feet, I want it to go up at 2%. Then for 80 feet, for 80 feet, I want it to go flat. So vertical with a 0 elevation change. And then I want it to go for another 20 feet at a -2. And again, this is going to elevate those side lot lines. So once I've set this, I do want to put this check mark for setting the back lot edge. So that would be this point here for that line. And I'm also going to copy all of these cut rules to the fill. So everything on the left side sets it for a cut condition. On the right side, it sets it for a fill condition. I'm going to hit Save As, and I'll just call it Civil Tips. And this is a grading rules file. And I will exit, and then I need to select that file for it to grade by. The reference template ID, again, I'm going to pick this, and for SH. The 2D lot layer is going to be 2D lot lines. It's going to output on a different layer, which is 3D lot lines. And it's going to look for anything, any polylines, anywhere from 10 feet to 500 feet off of that shoulder point. So I'll pick OK, save, and process this once again. And you can see in this case, because it created the new polyline, you can see the breakpoints. So this is my 12.5 feet at 2%, flat spot for 80 feet. Here's my 20 feet at a -2, and then tying back to existing ground. Again, let's use that 3D data label polylines command to label a polyline segment. So here's another little tip that I wanted to show today. So I have the slope set to be labeled above the polyline using a % for a suffix. I've got slope direction shown downhill. It will label a polyline segment, and I will draw the slope leaders. So all I have to do is pick on different segments of that polyline, and you can see how easily that's set up. So again, this is just kind of a start, give you a feel for what kind of grading can go on in a subdivision. All right, so I think that kind of has us set for what I wanted to show in the RoadNet. And let's move on now, and I'll close out this. Actually, I'll close my RoadNet to start with. And let's look at this new command that is in Carlson 2010, which is allowing you to easily set points on a slope. So let's just look to start off with. This is something I use in my training classes. So we're starting with a building with a finish floor of 211, and our instruction number 1 asks us, we first need to set the building pad at 211. Then we need to set points all around this little pad area. So I'll use set polyline to elevation, and I'll use the select option by typing an S, and that allows me to pick a piece of text, and then I can select on that building pad polyline, and I will turn on my layer inspector, sorry, my drawing inspector. And you can see that I have set that building pad elevation to 211. And so our step 1, we want to see a point set at 1 foot off the corner at 8 inches or 0.667 feet below the finished floor, and we're going to repeat that 4 times. So with this command, it's actually found, yep, I'm set to 30 scale, and the other thing I want to do is turn on my object snaps before I get started. So this command is found under 3D data. Under 3D points, we are setting points by slope. And the top section of this box asks me how I want to set the elevation of the point. So it's going to come from a known point horizontally and vertically, so it'll have a known elevation. And am I going to set the new point elevation based on a % from the original reference point as a ratio or vertical? For this first one, I'm going to go vertical because I just want to drop 8 inches from that known building pad elevation. And its placement method, the location, will be done by screen picking. So you've got to watch your command line. The top or the second line down here says reference point. So this is where am I coming from? And I'm going to zoom in and select on that building pad. So it reads the elevation. Now it's asking the target point, which will be the end point here. The delta Z, so from my original, it's going to go minus 0.667. and I will set a new CRD file, and this is just going to be BLDG offset. So building offset. And I want to do this 4 times. So since I'm coming vertically, so just a straight drop, I can just keep the same reference point. There's no need to change that reference point. So I'll pick here for my new target point. It prompts me for the new default for the delta Z, which is -0.667. Same description. And I can go to all 4 corners and set those building corners. Okay, so I'm done here. I'm going to hit my Enter key because I know I'm going to have to get out of this command. Step number 2 has me set a point at the PC and the PT, so at both corners here on my edge of pavement. And I want to come a -2% from that last point I just set. So I'll go right back into that same command, but this time I'm coming at a percent from my reference point. So I'm still screen picking. My reference point, I've got a point number I can refer to now. So my reference point is going to be 0.1, so I'll just type in 0.1. And my target point is going to set a new point here at a -2. The description is going to be EP. And from that same point, I can set this new point at a -2%. Same description. Now to do this point, we're going to have to change the reference point because it wouldn't be right to set the elevation from here if I'm basing it on a slope. So I'll hit my Enter key 1 extra time so that it prompts me for a next reference point, and I'll type in 2 here. Now I'm coming from point 2. My new target is here at a -2% and an EP description, and here at a -2% and an EP description. So without getting out of the command, let's look at what my next step, and I've got to actually go over here. I'm not going to do all of these, but our step 3 tells us that we want to set a point at a +2% from the nearest edge of pavement. So what that means is that from point 5 or 6, I want to go at a +2% to set this edge of pavement. So all of my parameters for this command are the same. I want to go at a percent, and I want to screen pick its location. So I can just simply hit my Enter key 1 more time to change my reference point. And I'll go from point number 6 to a target point here at a +2%. Same thing now. I'm going to go from point number 9 to set a point here at a -2%. So I hit an Enter key, change my reference point to point number 9, select here for my new target, and the slope in this case is a -2%. Same description. Now I have a little different case here. So in this case, I need to go from point number 10 to a point here at the midpoint between these 2 curves. But in doing that, I actually need to go around this curve and past this endpoint. So I can't just do a screen pick, because if I do a screen pick from point 10 to here, it's going to do a straight line distance. So I've got to hit Enter and get out of the command. We'll Enter to get back into the command and see what other options we have. In this case, I still want to go at a percent. It will be a -2% to go from point number 10 to here. But I'm going to follow a polyline, so that's going to give it a new path. Instead of doing a straight line distance from 10 to here, it's going to go around. So my reference point here is point 10. My target point, I'm going to snap to a midpoint here. -2% is correct. And then the line work to follow is here. So you can see it found the correct point. My new description is correct. And it set that elevation. Now to go to the next point, I'm going to hit Enter to change my reference point to number 11. I'm still in follow polyline. My target point is here. This time my slope percent is going back up at a +2, and then the line work to follow is here. And the description, and if it did it right, which it did, you can see that I ended up with an elevation of 209.01 here and here. And so pretty much on this, you could do everything with follow polyline from point 12 all the way around here to this point number 1. And what I want to do is I'm just going to skip ahead a bit so you can see that if you work your way around this drawing, you would come somewhere close to an elevation of 205.4 here and an elevation of 206.88 here. So what I'd like to find is a point along this polyline, so that if I came from this point 2 down at a -2 and from here down at -2, where along this line would they intersect those slopes? So we're wanting to find the low point. So under 3D data, 3D points, points by slope, we have an option for finding that placement based on the high or the low point between 2 points. So my prompt is first reference point, which will be point actually I'm going to snap because that's not a real point. So let's go to endpoint here. Reference elevation, I'm going to type in 205.4. Second reference point, I'll snap to here. And that reference elevation is 206.88. First slope percentage, so this percentage coming out of point number 2 is a -2. And the slope coming out of the old point 1 is also a -2. And the description is EP. And you can see that it has found that low point right there. So again, just a few options for you. Carlson has a lot of very handy ways to set points. This has really been a big hit in all of the training classes that I've done for surface modeling, as far as allowing you to set those points based on the way that we design. And then of course, once you have points set on these polylines, you can then use those points to elevate the polylines using 2D to 3D polyline by points. So again, hopefully that's something that everyone will find useful. So let's next look at the SiteNet feature. So this is the feature that, again, started out with the takeoff program and has migrated its way, luckily, to us over here in the civil program. And we're going to work exclusively under the SiteNet menu. So what I'd like to start off just by giving you a little tour around this drawing is under Inquiry, I'm going to go to the Layer Inspector and show you what layers we have shown. So, and I have absolutely done a lot of cleanup on this just for demonstration, making sure that it's good and clean and we won't have too many headaches. So you can see that I have building pads set to 2D. So these are all 0 elevation, they're for location only. I have a layer for 2D 0 elevation back of curb. And I'll skip through these for a second. And here's my 2D edge of pavement. So there's my 2D edge of pavement and back of curb. I've got a 2D retaining wall. And then I have some 2D sidewalk. Now I'm going to use SiteNet to determine my topsoil, the amount of topsoil that I'm going to need, being able to remove a foot, replace half a foot. And in order to do that, I've created another layer that is defined with the back of curb and my limits of construction. So the only thing that I've done on this 2D topsoil back of curb layer is made a copy of the back of curb layers, and trim them off at my limits of construction in order to make a closed polyline. So many things in this site net, because we're going to use it heavily to get quantities, it's going to rely on closed polylines to get areas and therefore volumes, because it'll be able to apply depth. So when we do volumes for topsoil, we need to have that closed in, and you'll see how that comes to play in a minute. So that's all of our 2D, and then we have a 3D back of curb and a 3D edge of pavement. The 3D edge of pavement, notice that I've closed it off. And again, you'll see in a few minutes, for the reason that we have to do that is in order to get a quantity of asphalt for a volume of asphalt in this case, and also a volume of stone as a subbase. Now the 3D back of curb is actually an open area. So the only thing I'm going to use the 3D back of curb is just to build that surface. Again, we'll talk about this a little more detail. The 3D pad layer is just a three-dimensional representation of the pads. So these have all been elevated based on the finished floor elevation. You can see here and here I do have a split pad. So I've got two different building pad elevations here. The proposed spot elevations, these are the points that I use to elevate the back of curb. And again, since I've used that to elevate and create my 3D back of curb, I'm not going to create those, I'm not going to build those into the surface. I've got three-dimensional walls that I have elevated based on my design. I've also got a layer for demolition for a fence. So again, this is part of the these are part of the quantities that we can use SiteNet to calculate for us. So anything on demo layer is going to be demolition. And then we have demo vegetation, so we have trees that need to be torn out. I have two layers for my existing contours, so labels and the contours. Everything again is elevated. This is my limits. These are my limits of construction. And I also have proposed contours, which again I've already built into my 3D back of curb layers. So I'm not going to use this for my surface, but it did come with the drawing. So let's just exit and now get right into SiteNet. So to start off with, what we do with SiteNet is we're going to define things pretty strictly by layers. And that's why the layers are so important, that we have a very clean drawing. I like to break things out, put 2D stuff on 2D layers and 3D stuff on 3D layers. And then we're going to designate each layer to be either part of our existing surface or part of our design. The other, so notice that we've got three different targets set here. So we have existing, design, and other. By default, everything is on the other, in the other category. So let me go back up here. So this is the define, layer, surface, material, and subgrade. Notice that on the three tabs, everything is under the other category right now. So I'm just going to exit that. I wanted you to see that existing and design right now are blank. Everything is considered an other layer. And I'll use set layer target and set layer for existing. And I'll go here, and I know these are on two different layers. So I'm just going to pick one of the labels, one of the contours. And you can see at the command line that it has set both of these to be part of the existing surface. If we go back to the define layer, surface, material, subgrade box, you can see that these two now fall on the existing tab. Still nothing on design, and everything else on other. Now again, this is a very simple drawing. I've got things broken out very nicely. And so this is the other way that I'm going to show you how to get things over onto that design tab that belong as part of my design surface. So I'll have to ask that you trust me for why I'm doing a few of these. You'll see it as we go through. But I want to leave my 2D building pad on other, but I will use my 2D back of curb layer as part of my design. I'm going to leave the topsoil layer here as well as the 2D edge of pavement retaining wall and sidewalk. So other layers for my design will be these. Actually, not even that. There we go. So I'm going to use the button here, switch this to design, and tell it to move all of these layers I have selected over to design. And you can see that they now fall here. So now what's the purpose of this? Let's actually, if I hit save and exit, because when it saves, it's creating a TRG file that it's saving all this to. Now if I go to SiteNet, actually let me just zoom out here. If I go to the SiteNet pull down, now currently everything is displayed, turned on, but now I can manage my layers by clicking display existing layers and turning it off. And if I go to display other layers, currently they're on. If I hit my enter, they go off. And so now everything that I'm showing here is meant to be part of my design, and I've made a mistake. So you can see that I've left those points on, and I really didn't want to. So I'll do set layer target, set layer for other, and I'll click on, actually all of that text is part of it. So now this is everything that I want to be part of my design calculation. So earthwork, materials, everything. So let's go back to SiteNet to define our layers. And you'll see why I picked the ones that I did. So everything that is in my design tab has one of two purposes. Either it's going to be elevated and be part of building and creating that design surface, or it's something I want to get a quantity of to report to me for materials. So for instance, if anybody's seen when you elevate 3D polylines that have a curve or an arc in those, you know that it kind of breaks up those curves. So I like to use a 2D zero elevation back of curve to determine what the length is. So if I double click on this layer, the material name, I'll just call this, I may call it 24-inch curb. This is a linear quantity that's going to be measured in linear feet. And you can see that it's showing me here, it's going to report this. The 3D back of curve is going to be used just simply to build the surface. But remember the 3D edge of pavement, that was a closed polyline. I'm going to use that to determine what my asphalt quantities and my stone quantities are going to be. So we'll just call this pavement. It's going to calculate it by area. And I'll just leave this to square footage right now. Actually, no, we're going to go to, I know this is wrong, but we'll do cubic yards. I think it's square yards. I always get confused. I want to report this in depth of inches. My first subgrade is going to be asphalt, and we'll do 2 inches. And we'll do stone underneath that for 6 inches. And you can see it's showing a depth of 8 inches. Building pad will be the same way. So this will be pad. It's an area quantity. And do cubic yard again for inches. And we'll have concrete here for 4 inches. And we'll do stone for 4 inches here. And then the wall is just, again, built, used to build the surface. Demo fence. This is going to be a linear quantity. And I'll change that to length. So I want it to measure how much fence we need to demo. And then demo vegetation. These are trees that need to be plucked out. So this is going to be a count quantity. And we'll say each, and the cost unit is going to be a count. And then The limits of construction, that's just simply a 2D zero elevation polyline that everything ties in grading-wise with. So again, changes are made here. I hit the Save button to save it to that TRG file, and I'll pick Exit. And now everything that I've done is set up for me. We have defined our layers. The next step is under SiteNet, and we have to define that boundary polyline. So I'm going to set the boundary polyline here. And so all of my calculations will take place inside. So I just noticed, actually truly just noticed, even though I've been working with this data set for a while, that some of the fence falls outside. So back under SiteNet, I've set the boundary polyline. My next step is going to be to make that existing ground surface. And all it does here, if any of you that have used Triangulate and Contour, you don't have to go through a lot of that when you're using SiteNet, because this is only taking that boundary polyline and the layers that we defined for the existing tab or the existing set of layers, and it's building a surface based on those. If I go to View, I can do a Surface 3D Viewer, and you can see it actually makes 3 copies, and there's a reason for those. But to see our existing ground, we'll go to EX, and you can see what my existing surface looks like. So we've got the mountain behind us. So back to SiteNet, next step is now to make the design surface. So again, it's taking inside that boundary polyline. It's looking at all of those layers that we've listed under the Design tab or targeted as design layers, and it's built that surface. And so now I can look at Surface 3D Viewer. You can see I've got 3 other layers, and this is FN, it's for our finished. And you can see how it's built and cut out for our building pad. So it has already taken into account the 8 inches of depth for that subgrade. It's taken in the 8 inches for our pavement. And it's not a bad looking surface. So I'll close and get out of this, and let's look at our reporting real quick. So under SiteNet, if I tell it to calculate total volumes, I'll pick OK. I can change my cut and fill factors if I want. I'll leave those at 1 for right now. And you can see what my cut and fill. So I'm definitely out of balance. And we're going to make that worse, I believe, here in just a second. So there's one other thing that we want to add. Actually, jumping ahead of myself. So that tells you dirt quantities only. If we go to SiteNet and material quantities, if I do a standard report, and I'm going to report everything, this is the report that we're given. So here you can see that our material that we labeled 24-inch curb, it's measured 2,348 feet. One thing to be careful of, just as a quality control issue, is the count, so number 4. So I know that for 24-inch curb, it should have counted this area, so the outside of the parking. Should have counted this back of curb that goes around this island area, and then I had 2 smaller ones. So that's correct. If you ever have duplicate entities, it will count them if they're on the right layer. So be careful. Pavement, it found 2 areas of pavement. So not sure that that's quite right. Oh, sorry, 2 entities. So, yep, so 2 entities, so 2 polylines that define the area. So it would be this innermost and then this polyline. So it is giving me a volume of 235 cubic yards of asphalt and stone, and again, you can change that reporting. It shows you I'm counting 2 inches for each. I'm sorry, 2 inches for asphalt, 6 inches for the stone. Here for the pad, it's given me those volumes as well. For the demolition for my fence, I had 5 segments of polyline that it measured for 1,011 feet. And then vegetation, it counted 13 trees that needed to be removed. It also tells me, and again for quality control, make sure that it skipped the 33 that you needed to skip. So for instance, I think I have trees outside, so I would guess that's a good number of what has been skipped here. And then just kind of finally, as we're getting to the end, I do want to show you how to work with the topsoil. And just from trial and error, what I have found is that it seems to me easier to create layers that are primarily for that. So bear with me here while I shift some layers around. I'm going to freeze my 2D back of curb, my 3D, and my edge of pavement. I will turn on that 2D back of curb topsoil and my 2D building pads. And now I'm just going to, I'll do an isolate to get rid of everything else. So I want to grab that. I want to grab the, all right, that didn't work. Let's see. I want 2D building pad and I want my limits. And that's it. So these are the polylines that I'm going to use to determine my topsoil quantities. So under SiteNet, topsoil remove and replace, step 1 is to define the topsoil depth. Removal depth, I'm going to set this is in feet, so I'll set that to 1. So I'll remove a foot and replace half a foot. Again, you can get fairly detailed on your swell and shrink factors, whether it's calculated perpendicular to the surface or just straight down vertical. Back to SiteNet. Next step is to set the topsoil removal polyline. So what is the polyline that I want to remove all the topsoil inside of? Well, this is my polyline for my limits of disturbance. So I'm going to remove topsoil everywhere inside of this. So I'll pick my Enter key. And Carlson has a really cool check here. So under topsoil remove and replace, now this middle area is from removal. I can actually hatch that topsoil removal, and you can get a visual indicator that it's going to remove what you want it to remove. And then I will go back in and just erase that topsoil removal hatch. And then exactly the same way, I'm going to go to the third group here and set the topsoil replacement polylines. Again, what's critical is, 1, they have to be polylines, and 2, they have to be closed polylines. And everything on my screen, except for the text with the leaders, are closed polylines. And that's what it has to have in order to calculate this properly. So if I pick concentric, not concentric, but closed polylines within closed polylines, and I can just put a window around everything, it's going to calculate the area and figure out the area in and around each of these closed polylines to determine what my topsoil replacement will be. And again, I can go back to topsoil replacement and hatch those areas to make sure that they come out the way that they are supposed to. And you can see, even inside the little islands, that it has done those properly. So again, this is your best indicator of whether it's going to do what you mean for it to do. So I'll remove that hatch, and then after I make those changes, I like to save. And then I need to go back, because both of those settings that I just changed, which were removing topsoil and replacing topsoil, are going to affect quantities in my existing and my proposed. So I'll make the existing ground surface again. And I'll go right back in and make the design surface again. And now with SiteNet, let's look at the difference. If I go to calculate total volumes and OK to this, you'll see I've got some extra information now. And so it has calculated what the volume of topsoil to be removed and how much is going to be replaced. And it has taken all of that into account with our new cut and fill volumes. So all that being said, that is SiteNet. That is kind of the power behind it. Again, I'm not going to gloss over the fact that it does require some cleanup. You really do need clean polylines, need a drawing with clean layers in order to get it to work to the best of its ability for you. So I think with that, we didn't get to multi-pad grading. We'll have to save that for another time. But Lad, do you have any questions?
Nope, absolutely, Jennifer, great job. Everything right now, the queue is sort of empty, so great job on the presentation. And we'll be recording this session, actually have recorded, and we'll be posting it to the Carlson website here shortly. So for anybody who wants to revisit this and the content that Jennifer presented today, you'll have that ability to download that, the movie probably either later today or first thing tomorrow. So with that, thank you, Jennifer, for your time and all that wonderful information, and we'll go ahead and conclude.